In this video, we're going to go over E2 reactions and talk about Zaitsev's rule. When you have an E2 reaction, a strong base is required, such as sodium methoxide. On sodium methoxide, you have 3 lone pairs of electrons. And I have drawn an expanded structural formula here for illustration. 2 of these pairs of electrons are going to attack this hydrogen, breaking it away from the compound. It is only going to take the hydrogen, leaving behind the 2 electrons. These 2 electrons are going to be attracted to the positive character of this adjacent carbon. So to show the electron flow with an arrow. When it attacks this adjacent carbon, this bromine is already tugging on the 2 electrons in the bond. So when this attack from these pair of electrons that were on the hydrogen attacks the carbon, these pair of electrons are going to break off onto the bromine. And when you do that, you form a double bond, or an alkene, as such. Now you might ask, why does this pair of electron on the base attack this hydrogen and won't attack one of these hydrogens? Well, technically, if you put this in some beaker or flask or wherever you're doing your experiment, you probably will get a little of these mixtures. But Zaitsev's rule says that the attack is going to take place at the carbon that is the most stable. This benzene ring here stabilizes the carbon. But even if you only had, say, just another carbon like so, say if this carbon is this carbon and you had another carbon over here, this would stabilize this carbon more than with this carbon, because this carbon is only bound to one other carbon, whereas this carbon would be bound to 2 carbons. So when you look at Markovnikov addition reaction or Zaitsev's rule in the elimination reaction, the reaction is going to take place at the carbon that is the most stable. Also, when the base attacks this hydrogen, it becomes this compound here, which is the exact same compound as the solvent. So it essentially becomes more of the solvent that already exists in the reaction. The sodium is an ionic bond, and it does not participate in this reaction. When you see 50 degrees Celsius or 25 degrees Celsius, etc., it simply means that heat is required for the reaction to take place.